bit. So what that's going to mean, real numbers, the three are going to focus on today are integers, decimals, which are a rational number, and fractions. And we don't have to do all of these, right? I'm looking at this as like we can get a vibe as a class and see kind of things we need to work on. But the one thing I want to take you through is an experiment. And this experiment is going to justify why a negative times a negative is a positive. Because I think everybody knows it, but nobody could explain it real well, why it works, right? Is that, do I have a good pulse here? Like, you know it does it, but it kind of doesn't make sense. Like, I have negative something, and I multiply that by negative more, why is it positive? Well, there's a little experiment we can do. So we're going to start by justifying why a positive times a negative is negative. We're going to start with that. Okay, so follow me here. 4 times 4 is what?
16.
Okay. 4 times 3, 12. 4 times 2. So what do you know is happening to my product?
It's getting smaller.
Yeah, it's going down 4. And that's because I'm multiplying by one less. Yeah, I'm having one less of those 4s. So let's keep the pattern going. 4 times 1. 4 times 0. So without even looking at my next problem, if I go down 4 again, I'm going to go from 0 to what?
-1.
Negative 4. 0 to, oh, you were looking at the other 0, James. That's good. So if I multiply by -1, my product has to still go down 4 to -4. So this justifies why a positive times a negative is a negative. We good there? Do you see? All we did is follow a pattern even. Okay? So we're going to do that same pattern. We're going to go over here. Let's start with a -3 times 4. What is that? And I can say that because we just identified and justified one of each is negative. Okay? So let's do -3 times 3. What is that?
-9.
Let's do -3 times 2.
-6.
So what's happening to my products here?
They are getting. They're going up.
Up 3 because I'm having one less negative, right? Each time. So you see that one less negative happening right there. So -3 times 1 is what? -3. There's that plus 3. So -3 times 0 is up 3 to 0. So what's my next answer even if I don't write it?
3.
My next answer has to be 3. And if I keep going down 1 for what I'm multiplying by, I would have to go to -0 or -1. So that justifies right here why a negative times a negative has to be a positive. It's just an extension of our pattern. So how cool is that? You can justify a positive times a negative is a negative by extending your pattern of products. Then you can take that understanding, extend your pattern of products to show that a negative times a negative is a positive. That's why it works. It's pretty cool, huh? So I call those, in this class, you'll hear it as a thought experiment, inquiry. We do quite a bit of this where you're going to build an understanding by like kind of working through some patterns or some things with numbers and coming to a conclusion of, you should trust me when I tell you a negative times negative is a positive. But I also want you to see like I'm not just voodoo making some junk up. All right? This is real stuff that's happening. We good with that? This is pretty easy to replicate in a lot of different math too. Like if you don't know how something works, you can try out a little experiment and look for patterns. So the next thing I want to look at with you is multiplying decimals. It maybe has been a minute, okay? So there's 2 different ways you can look at multiplying decimals. And let's get one that's like -1.27 times 3.4. Okay? So, you know, the way that your teacher probably said to do it is you do your traditional multiplication algorithm, no decimal in it. So I'm just going to do 127 times 34. Okay.
Forgot how to do.
Is that point or is it?
Okay, so I got 4,218 if I did 127 times 34. And then you probably learned in class that there are 2 after the decimal there, 1 after the decimal there. So I need to have 3 after the decimal here as well for 4.218. And I had a negative times a positive, so that's going to be negative. Now, there is something else you can do to get the decimal in the right spot. This number right here is kind of close to 3. This number right here is kind of close to 1. What's 3 times 1? 3. Where's the only spot you could put a decimal anywhere in that number where it's even close to 3? Between the 4 and the 2. So that's another thing you could do. You could use estimation to get the decimal in the right spot.
That's what I.
Because if you put it before the 4, it's nowhere close to 3. If you put it after the 2, 42, that's nowhere close either. Right? So there's 2 different ways. So that's multiplying decimals. I see some people writing some stuff, so hold up a sec. We're going to skip multiplying fractions because once we look at a divide fraction, you end up multiplying, so we can get a twofer. So something like negative 1/6 divided by negative 2 1/3. That might be like the toughest division problem I ask you to do tonight. Okay? And here's how you remember how to do what a division problem is. Whenever I would forget, here's my little thought bubble. I would remember that dividing 10 by 2, which is like 10 divided by 2, is the same as multiplying 10 by half. Like we intuitively know that, I think. Half of 10 or 10 divided by 2 is half. Right? So what do you notice about the symbol and the divisor?
They're both.
It's flipped. The reciprocal. Reciprocal means what can you multiply by it to equal 1 technically. But it's the flipped. So I hear people say stuff like he changed slip. Yeah, you can remember that. Yeah, that's the action.
Change.
Everybody's going to know how we're dividing fractions. Okay? So I don't do keep, change, flip. I use the reciprocal understanding that it's really the same thing. So what that means for this problem is you're going to want to use your second mixed number. You're going to want to use mixed numbers as improper fractions usually. So that's the same thing as negative 7/3. That does not look like a 3. Okay, so I'm going to have negative 1/6. I'm going to change division to multiplication. But in order to do that, I have to use the reciprocal. So that's going to be negative 3/7. Cool? Same problem. I just changed the way it looked. So this is why I'm not doing a
Wait.
multiplication
I
line.
remember this.
So James, all I did was this is the improper function form of this fraction here.
Oh, yeah.
And then I
flip it
multiply
around.
by the
Oh, yeah,
reciprocal.
now I get it. I see.
Okay, next thing you're going to want to do is use cross simplification to make it easier. You don't have to, but you're going to want to.
What is that?
So I can divide that 3 by 3, and I can divide that 6 by 3 to get negative 1/14. And I'm going to show you why you can do that. A lot of kids know you can cross simplify, but they don't know why. Here's the why. Let's do it in a different color.
Yeah.
Negative 1/6 times negative 3/7 is what I was doing. So let's say you did the top times top, bottom times bottom, you'd get 3/42, correct? Okay, check this out. Watch what happens if I flip my numerators. If I have negative 3/6 times negative 1/7, I get 3/42. What do you notice happened to my answer when I flip my numerators? It's the same, because of the commutative property of multiplication, right? 1 times 3 is 3 times 1. So look at this fraction, though, once I changed them. What do you notice you could do with that fraction? Simplify it. Divided by 3, I get 1/2, guys. So instead of doing all that work to get that fraction you can simplify, you can just identify on these fractions here. That's why you can cross simplify. Cool? Isn't it nice to see, like, I know I could do this thing, but isn't it nice to see why you can do it? Yeah, it all goes back to the commutative property of multiplication, which you saw, like, last year and probably the year before, too, right? Titus.
So I'm still not getting how you're crossing.
Okay. So we're going to go back to the understanding here. So did you see how 1/6 times 3/7 was the same thing as when I moved the numerators?
Yeah.
I got the same exact answer. Okay? But when I moved the numerators, see how I had this 1/2 fraction right here?
Yep.
I could make that 1/2. That's all I did. I just didn't move it around.
Ah.
You know, that way I don't have to rewrite stuff.
Yeah. All right.
It's based on this understanding right here that I can do the cross simplifying here. Cool? Great question. Isn't that nice? It feels good to me to know why something works. You should trust your teachers. Your teachers know stuff. But it's good to know why it works, because that'll help solidify the understanding, and then you won't get that summer rush like, oh yeah, I remember doing something like that. Okay, that's why I focus on understanding, not procedure. All right? Your homework is the last 3 pages attached to the Google Calendar. Get after it. You got some time.